Our plot of land is mostly high ground without a naturally occurring source of water. This means we will need to design and build systems that can ensure water security. As any system is bound to break down at some point, we will create three methods for accessing and storing water: wells, rainwater collection, and ponds. In the center of the camping area, located in the northwest part of the property, we may be able to drill a well ourselves and connect a hand pump to it, similar to what one might find at a public campground. We will have a standard well professionally drilled to provide water for the welcome center and the cabins. Finally, a high-capacity well is needed to supply the domes and the main residence. Now, to get the water up and out of the standard and high-capacity wells as quietly and efficiently as possible, a pump designed specifically for off-grid systems makes the most sense. The best pumps are made by a company in Denmark called Grundfos, and while they are more expensive, the energy savings and durability they provide will be well worth the cost. The domes will have tanks capable of storing large amounts of water, and they will be topped off as needed by the high-capacity well. Some of them will also hold rainwater, bringing us to our second method of three: rainwater collection. The large surface area of the domes will work well for this throughout the year, as the winter snows can also be melted off and collected. Before we get to the third method, let's talk for a minute about how we will deal with the water after we use it indoors. Composting toilets mean we won't need to deal with any black water. Gray water is much easier to process and will be drained to the domes and filtered through reed beds. This process uses gravel, sand, and plants to remove any unwanted contaminants before releasing the clean water. The third and final method is to dig a large pond at the bottom of the hill next to the main residence. This will be a permanent source of water and a place for swimming, ice skating, fishing, and wildlife. Water stored in the buffering tanks under the dome will continue to flow through the subtropical climate, irrigating plants, providing habitats for fish, a place for us to swim year-round, waterfalls that not only look nice but oxygenate the pools below them and help to regulate the temperature of the domes. This is a form of geothermal heating known as an open ground loop, which takes the constant temperature found underground in the water table and brings it up to the surface. Once the water has run its course through the domes, it will simply soak back into the ground during the winter months. When the weather warms up, it will be redirected outside. Canals and ponds will line the northern side of the domes and the residence, irrigating orchards and gardens, along with providing the means for a fire suppression system. Pumps will be installed to spray the water out of the canals in case of a forest fire. From there, the water can continue down the hill and into the main pond below. As the water travels down to the main pond, some of its energy could be captured using a turbine. A pump can also be installed in the main pond to bring water back up to the higher ponds as a backup to the high-capacity well, and also to store excess energy, although it would be an inefficient way to do so. We will discuss more ways to capture and store energy in the following video.